Welcome back everyone to our first lecture on NumPy, where we're going to be discussing NumPy arrays. Let's open up a new Jupyter notebook and get started. Alright, so to start off, what we're going to do is just import NumPy, and you just import it. You can just say import NumPy, and by convention it's as NP. And what we're going to discuss here is NumPy arrays. NumPy arrays are the main way we're going to be using NumPy throughout the course. NumPy arrays essentially come in two flavors: vectors and matrices, where vectors are just one-dimensional arrays, essentially just a straight list, and then a matrix are two-dimensional. But you should note that a matrix can still have only one row or one column. So don't worry about that terminology too much, because sometimes people tend to mix them up a little bit. All right, let's start with just creating a NumPy array. So how to actually create a NumPy array. Well, you can create a NumPy array through various methods. One thing you can do is if you have a list, 1, 2, 3, you can cast that to an array. You can say np dot and then call the array function. You can do shift tab here to find out more about it, but essentially you just pass it an object such as a list and it will output the array. And note what happened here. Jupyter's actually telling you, hey, this is no longer just a normal Python list, it's actually an array. And if you want to confirm that, you could, for instance, save this as a variable x and then check the type of x. And you can check that it's now a NumPy ND array. So that's one thing you can do. If you actually want to build a matrix, you can create a variable called matrix and have a nested list. So that's a list of lists. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. So note what I have here. I have a list with 3 items in it, and each of those items is a list itself with 3 additional items. So now if I pass this to NumPy array, pass in my matrix, I get back an array, but the actual dimensionality has been taken into effect when displaying the output. So NumPy is smart enough to realize that this is a two-dimensional array or a two-dimensional matrix where I have 3 columns and then 3 rows. And each dimension is notated at the very end with a set of brackets. So one set of brackets is one-dimensional, 2 sets of brackets it's two-dimensional. You can go to 3 sets, 3-dimensional, 4-dimensional, etc. For financial data, we really don't go beyond 2 dimensions. Sometimes we hit 3, depending if we want to include another feature, but really it's just 2D data we're working with. Okay, so let's discuss a few built-in methods to generate arrays. Sometimes when you're working with financial data, you want to quickly model something that is either random or straight zeros or straight ones or straight fives, etc. And NumPy is a really nice way to quickly create an array like that. So if you remember, we have the built-in range function in Python. So if I cast range from 0 to 5, that gives me back a list of integers, 0, 1, 2, 3, 4. There's actually a NumPy version of this, and it's a range. Note that there's just one R there. And it basically works the exact same way. You say np.arrange 0, 5, and it creates an array version of that list. So NumPy's version of range is just a range. So you can think of it as like array range. So that's one way to do it. And just like range, it can take in a starting point, an end point, and then a step size. So this gives me back all the odd numbers starting at 1, going up to, but not including 11, and step size of 2. That gives you all those odd numbers. If you wanted the even ones, you would start at 0. Okay, so let's continue along and talk about generating arrays of zeros and ones. And this will be useful in case you ever want to do some sort of financial model. So we'll say np, and we'll call zeros. And zeros allows us to quickly create an array or a matrix of zeros. So if I just pass in one number here, it returns an array of 3 zeros. And note that we see here there's 0 dot, and that basically indicates that this is a floating point number. So there's 2 major types of numbers in Python. There's a single integer, such as 1, and we can check this. We can say type 1, it produces integer. If I say type 1.0, it produces a float. When we're working with NumPy and pandas and start doing operations on our numbers, even if we take things in as an integer, usually, especially with pandas, it will convert it to a floating point number to make sure you don't lose any data. That way, if you have something like 0.5, it doesn't accidentally get round down to 0 or round up to 1. So that's why when you produce zeros, you get this little dot there. It just stands for a floating point. So that's how you can create a one-dimensional array. Again, just np zeros, and then pass in how many numbers you want in the array. You can actually do this for 2 dimensions as well. You'll say np zeros, and then you can pass in a tuple or a tuple of dimensions. So if you want 5 by 5 matrix of zeros, there you have it. If you wanted something like a 3 by 5, you have that. So remember, 3, this very first one at index 0 of this tuple, stands for how many rows you have. Index 1 over here stands for how many columns you have. Similarly to zeros, there's a ones function, and as you may have guessed, ones operates the exact same way, except it gives you back an array of ones. And again, you can pass in a tuple of dimensions, so 3 by 3, and that gives you back a 3 by 3 dimension of ones. Now, if you want to return evenly spaced numbers over a specified interval, you can use linspace. And linspace is a little different than range. Let me show you how. So we can grab linspace by saying np.linspace, and this stands for linearly spaced. So it takes in a start, a stop, and then a number. And what that does is it returns evenly spaced numbers over the specified interval of start and stop. So it's a little different than a range. Remember, a range just takes your starting and your stopping and then gives you in 1 step or 2 steps or whatever step you wanted, it just gives you integers. Linearly spaced is a little different. You take a stop, or excuse me, a start and then a stop, and then you ask for how many numbers you want in between the start and the stop. So if I want 3 evenly spaced numbers between 0 and 10, I get back 0, 5, and 10. I can also change this to say, give me back 30 evenly spaced numbers between 0 and 10. And then you get back 0, 0.34, etc. However, these are all evenly spaced. So the space between this 0 and this 0.34 is the same space between 0.34 and 0.68, same space between this one and the next one, and so on. So that's linearly spaced. It's spacing them out evenly. So then we can do things like give me 50, etc. You can say give me 51, and you can get starting at 0 in spaces of 0.2. Something to keep in mind, it's a little weird if you're not thinking of indexing starting at 0. You may suspect that this should have been with 50 to get those 0.2s, but because indexing starts at 0, you usually have to do either +1 or -1 to get these nice little even cutoffs. So that's linearly spaced elements. There's also an identity matrix that you can call with just the I function, so it's np.I, and this actually just takes one number in, because an identity matrix is a square matrix, square meaning that it has the same number of rows and the same number of columns. An identity matrix is just a matrix of zeros where the diagonal happens to be 1. So that's an identity matrix. Alright, now let's take the time to talk about NumPy's random library. NumPy has lots of ways to create random number arrays. And when we're working with financial data and we want to kind of randomly model something like a Monte Carlo simulation, we're going to be using NumPy's random module. So let's go over how it works. The first we end up doing is say np.random, and then you're going to say dot, and if you hit tab here, you'll notice that there's a bunch of different methods and distributions you can use for creating random numbers. So what we're going to end up doing is saying rand off of random, and if you do shift tab here, it basically kind of explains what this is going to do. So what this does is it says random values in a given shape. So it's going to create an array of the given shape and populate it with random samples from a uniform distribution over 0 to 1. So what is a uniform distribution? A uniform distribution basically says that all the numbers between 0 and 1 have the same probability of being picked. So if I just ask for one random number between 0 and 1, I get back an array of 0.18. And if I run this again, I get back another random number between 0 and 1. Notice these are floating points, these are not integers. I can also pass in multiple numbers here, and what this says gives me a 5 by 5 matrix of random numbers between 0 and 1. And this formatting looks a little weird, so let's make this kind of a little smaller so it looks a little nicer. There we go. Now we have a 5 by 4. All of these random numbers are between 0 and 1. And all of them come from a uniform distribution, meaning every single number has the same odds of being picked. The next thing we're going to discuss is sampling from a random standard normal distribution, which unlike rand is not uniform. So we can do np.random.randn, and if you do shift tab here, it'll give you information saying this is returning from a standard normal distribution. So a standard normal distribution basically looks something like this right here. You have the mean centered around 0 with a variance of 1. So the closer you are to 0, the higher probability you have of the number being picked. Unlike uniform, where every number between 0 and 1 had the same odds of being picked. Now keep in mind, if you expand this here, and let me zoom out just a little bit so we can read this a little better, it'll say down here that this is from a standard normal distribution. It's sometimes also known as a Gaussian distribution, and it has a mean of 0 and a variance of 1. So given that the mean is at 0, that means we can actually get negative numbers off of this, and the variance is 1. If you actually want to kind of supply your own arguments of where the mean should be, what the variance should be, etc., there's other functions you can use, stuff like numpy.random.standardNormal, and then you could do numpy.random.normal, etc. There's a lot of functions for you to kind of play around with there. So we'll just use rand_n, the standard normal distribution, and what we'll say here is, let's say, give me 5 numbers. And now we can see there's 5 numbers here randomly chosen from the standard normal distribution. So then we can say, give me a 5 by 5 matrix of numbers. Or let's do this again with 5 by 4, so it looks a little nicer. Okay, so you can see here, instead of being a uniform distribution from 0 to 1, now we're doing a standard normal distribution centered at 0 with a variance of 1. And you can see that the closer you are to 0, the more likely probability you have of being picked as a random number. If you just want a random integer, that's also pretty straightforward. You just say np.random.randint, do shift enter here, and it just returns a random integer from low to the high. And the high is exclusive, just like we've been dealing with for list indexing. So you end up saying, okay, give me a random number anywhere between 1 and then up to, but not including 100. So there you have it, just a random integer. And you can keep calling this, and you'll keep getting back different random integers between those 2 points. And if you actually want more random integers than that, you can specify kind of a third argument here of the size of your array. So you can see, give me back 10 random integers between 1 and 100. 1 inclusive, 100 exclusive. Okay, now let's discuss a few array attributes and methods that are useful. I'm going to create an array. We'll say a variable ARR. Let me zoom in one level here. So ARR, that's going to be equal to np.arrange, and we'll say 25. And then I'm going to say, give me a ran array. That's just going to be np random, just some random integers, let's say between 0, 50, and give me 10 of them. Okay, so we have our array here. And then because I'm zoomed in, the formatting looks a little different, but if I start zooming out, you'll see that the formatting kind of fixes itself. So I'll stay zoomed in. If you get different formatting than me, don't worry. That's just a display thing. And then the random array looks something like this, just kind of some random integers there. Okay, so a really common method to use is the reshape method, and that returns an array containing the exact same data, however with a new shape. So if I take a look at my array, right now it's just a one-dimensional array. It goes from 0 to 24. I can call reshape on this and reshape it into an array of a different size. For example, I could reshape it to a 5 by 5 matrix. And now I have the numbers in a 2-dimensional matrix, 5 by 5 dimensions. Now keep in mind, if I try to do something like 5 by 4, you'll end up getting an error because it can't reshape a size 25 into a shape 5 by 4. A quick clever trick for this is just these 2 numbers right here need to multiply to equal this one. So we could do this with 20 numbers, but I can't do it with 25 numbers. So 5 by 5 ends up working because 5 times 5 is 25. So you have enough spaces to fit in all those numbers. So that's the reshape. It's really useful for quickly creating a matrix. Then we're also going to discuss the shape attribute. So the shape attribute is just a shape of the array. So if I take a look at my original array, that is this guy, what I can end up doing is asking for the shape attribute. And note, it's just an attribute right here. And it says back 25 comma nothing. So essentially what this indicates is that this is a one-dimensional array. So it just has 25 on one axis. If I were to reshape this into a 5 by 5 and then call .shape off of that, I end up getting, hey, now your dimensions are 5 by 5. And I could reshape this to be 25 by 1, which is basically going to, instead of having 25 columns and one single row, it's going to have 25 rows and one single column. So let me show you what that looks like real quick. So now the dimensions look like this, and if I ask for the shape, it's going to say, hey, now you have a 25 by 1 instead of just a straight flat 25. So that's kind of the difference between seeing just 25 comma versus 25 comma 1. So keep that in mind. If at any time you want to know the data type that your array is holding, you can just grab your array and ask for the dtype attribute, and it returns back what kind of integer it has, or what kind of float has, etc. So you can see here, this is int 32, which just describes, has like 32-bit integers in there. Finally, we're going to discuss 4 key methods that are really useful, and we're going to do these off the random array. So because this is a random number array, you may not get the same values I have here, but that doesn't really matter for our purposes. If you ever want to grab the max number in an array, all you need to do is call the max method, and this returns back the highest or maximum number here. In our case, it's 37. Your number may be different. If you actually want the index location of where this max number is, you can call argmax. So argmax, what it does, it returns the index location of this maximum value. So if you go to index 7, so 0, 1, 2, 3, 4, 5, 6, 7, I can see here that's where my maximum lies. And similarly, there's the min, which gives you the minimum value, and then there's argmin, which gives you the index of the minimum value. So my minimum value is at index 3, the number 6. Okay, and that's really it for the basics of NumPy arrays. Thanks everyone, and I'll see you at the next lecture.